Hi, welcome back. Once again, I am welcoming you all to this beautiful online learning platform, Unacademy. Unacademy is the India's largest online learning platform. Now we are happy to announce that Unacademy is going to providing online training for GATE and Engineering Service Exams. GATE and Engineering Service Exams with India's top educators. About myself, I G Venkata Sir. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE examination. At present, I am pursuing PhD from JNTU Kakinada, and my specialization is VLSI design. Now, here first we check how to get Unacademy learning app into your device. Just go to Play Store, type Unacademy, then it will show the Unacademy learning app like this. By clicking on this install button, it will install the Unacademy learning app into your device. Now, what you will get by joining Unacademy, what you will get. See, first and foremost thing is daily you have a live class. Every day you have a live class. Next, structured courses, live tests and quizzes, unlimited access. Now, daily live class, what it means? Every day you have a live class. Every day you have a live class. And the intention behind to conduct live class and every day is always to keep the student in touch with the subject. With that intention we are conducting that. And in that class you can chat with your educator, it means with your faculty, and you can engage in discussions. And you can ask your doubts and answer the polls. So you can perform all these things while class is going on. You can perform all these things while class is going on. After that, structured courses. See, all our courses are structured in line with your exam syllabus and to help you best to prepare for it. Whatever the courses we have, every course is well structured with its exam syllabus. Then it is very easy to the students to continue its preparation. After that, live tests and quizzes. See, once you complete your preparation, you need to write more number of mock tests as well as quizzes, because to evaluate your preparation you need to do that. And after writing the tests and quizzes, we give the detailed analysis on your performance. That is what this. So you can evaluate your preparation with our regular mock tests and quizzes and get detailed analysis on your performance After that, unlimited access. So once you get the subscription, you can get access to all our live and recorded courses to watch from the comfort of your device. So once you take in a subscription, you can watch you can get the access to get all the live classes as well as recorded classes. Okay, all the classes you can get, and a number of times you can watch. There is no limitation. And one most important thing is, whatever the comfortable device you are feeling, either laptop, desktop, mobile, tab, whatever it is, whatever the comfortable device you have, you can watch it in that device. These are the things you get by joining Unacademy. See, here there are two subscriptions: iconic subscription and plus subscription. This plus subscription is the basic subscription. In this, just before, what are the things I explained? What you get: daily live classes, structured courses, live tests and quizzes, unlimited access. All these things you get by taking plus subscription. So by taking plus subscription, you get all these things. Okay, next, iconic subscription. See, iconic subscription, it will take your GATE and ESE preparation to next level with personal coach. With personal coach. Now, first of all, what are the benefits got by the plus subscriber? You get all these benefits. In addition to these benefits, you get the personal coach. Next, study tracker you have, and mains question and answer practice. Personal coach, what it is? See, you get one-on-one guidance from top exam experts. This top exam expert is your personal coach. We allot top exam expert as personal coach to each and every student. Okay. Now, once you've written the exam or you attempted a quiz, this personal coach is going to do the analysis on your performance in that exam or quiz. Based on your performance, they will prepare proper study planner as well as respect to study material to you. Okay, that is the function of the personal coach. And after that, study tracker. So you can evaluate your progress in by weekly reviews with your personal coach. For that, you need to participate in study tracker plan and study booster workshops. Okay, and after that, mains question and answer practice. Mains question and answer practice. Okay, you can strengthen your mains answer writing through regular practice with evaluation and personalized feedback. See, once you are taking the ESE engineering service exam, there you need to answer the mains paper. Okay, now answering mains paper is a different compared to the writing the GATE exam. In mains paper, you need to write the descriptive questions. You need to answer the descriptive questions. So first you need a thorough preparation for thorough practice how to answer the mains questions. Okay, you can do that here. Now you can strengthen your mains answer writing through regular practice with evaluation and personalized feedback. Okay, so these are the things you can get from mains question and answer practice. These are the additional benefits you get by taking iconic subscription. Okay, after that, yeah, combat. Unacademy combat is going on. It was completed already in the month of April and March and April. Now in May also it is going to continue. In this, if your rank is between 1 to 3, and you get a complimentary Unacademy Plus subscription for 1 year. And if your rank is between 4 to 10, 75% off on Unacademy Plus subscription for the tenure of your choice. 75% subscription. Okay, 75% off on Plus subscription. Now your tenure is, you can take either 6 months or 1 year or 18 months or 24 months, 2 years. For rank 11 to 50, 50% off on Unacademy Plus subscription. The same thing for tenure of your choice. For rank 51 to 100, 25% off on Unacademy Plus subscription for the tenure of your choice. Now, first of all, in this combat, what you get? First of all, what you practice from this is you are going to writing India's largest weekly competition for GATE exam, and you can assess your GATE preparation in 60 minutes. You can assess your GATE preparation in 60 minutes, and challenging and original GATE questions curated by the best educators. Challenging and original GATE questions curated by the best educators. Now these are the eligible departments: mechanical engineering, civil engineering, electrical engineering, electronics and communication engineering, computer science and IT departments. And take it live to compete with the best. So compared to the topper where you are, you should know this from this. and super fast and fun with all India live leaderboard. That means based on your fast and accuracy of answering the question, your rank is going to be decided compared throughout India compared to all India rank. Now identify, see, after completion of the exam we provide a detailed video solutions to you. From that you can identify your weak areas. That means the questions what you are not understand or not answered properly, you can get the solution of that question in a detailed manner, and you can improve your weak area from the detailed video solutions. Already May 2nd was completed. Next combat is on May 9th. Don't forget. And the exam will start at 11 a.m. Now to unlock, use my code VRAO10. So this is the enrollment guidance for scholarship test. First start and enroll for free from Android mobile. After enrolling, you appear live for the test. After writing the test, you get the detailed video solutions. Now take the video solutions of those questions and weekly practice those things. Every day, every weekly you are getting these type of solutions, questions and solutions. Practice like that few weeks. Finally you win the scholarships. Okay, this is the process you can follow for getting a better result, for getting a best rank in scholarship test. Now next topic is amplifiers frequency response. See, what is this frequency response? First, what we understand from this, how can we see this frequency response? Okay, just a minute. Now first of all, now let us say this. Here I am taking an amplifier. So this is our concept. Frequency response. First of all, let us, I am taking an amplifier. And another amplifier. The same amplifier let us take. I am copying this same amplifier. So these are the amplifiers I am going to be using here. Okay. Now in this amplifier, for this amplifier I am going to apply some input signal. Default we are applying input signal is a sinusoidal signal. Similarly here also I am applying this signal. But you observe one thing, from first amplifier to second amplifier, second to third, frequency of this signal is increasing. Frequency of this signal is increasing. Now this amplifier provides an output signal like this. see, compared to this, amplitude is increasing, so signal strength is increasing. In this case also your signal strength is increasing. Here also signal strength is increasing. Same signal frequency, from here to here frequency increasing, signal strength is increased here, but in this case signal strength is decreasing. Means whatever the frequency you are applying, let us take it as a gain. Once increasing frequency, from here to here frequency is increasing, okay, strength is increasing. Whatever the amount strength is increasing here, the same amount here also strength is increasing, so gain is constant. And at high frequencies signal strength is going to be decreasing. That means your amplifier is unable to amplify all frequency components equally. Amplifier is unable to amplify all frequency components equally. Okay, it is not amplifying all frequency components equally, that is the problem. Okay, now so for better understanding this, we go and take another example. Okay, so let us take my question and try to think about it. See, if you are taking our voice, see, why people's voice, people voices over the phone sound different from their voices in face-to-face conversation. Face-to-face conversation. Face-to-face conversation. Okay, that means why people's voices over the phone sound different from their voices in face-to-face conversation. For example, you are speaking, you are talking with your family members face-to-face. In that case, face-to-face transaction, your voices at the same time. In mobile, if you are speaking with them as with your mobile, in that case both are different. Why? Because in face-to-face while we are speaking, our frequency while face-to-face is human frequency range. In face-to-face this is the case. In face-to-face this is the frequency range what we are using. This is a 20 Hz to 20 kHz. See, the bandwidth is approximately 20 kHz. The bandwidth, huge bandwidth. Okay, but in mobiles bandwidth is limited. In phone conversion, in phone, so in phone frequency is limited, very small bandwidth is not that much, so your bandwidth is limited. So it is in generally 400 Hz to 3.5 kHz approximately. See this, approximately it is 3 kHz. Here bandwidth is limited. Here bandwidth is more. That's why your conversion from face to face is different and in mobile is different. Okay. Now, after that, to understand this frequency response in a better way, first we go and check the simple low pass filter. We get the low pass filter frequency response, we check it. After that, we are applying that low pass filter concept to your amplifier frequency response. Now first low pass filter. See, your low frequency low pass filter is like this. Here we are applying input signal. And it is the R1, let us, it is C1. Okay. Here we are taking output. For low frequency, reactance of capacitor is high. So first point is, for low frequency, reactance of capacitor C1 is high. Of capacitor C1 is high. Once its reactance is high, therefore output voltage is high. V output is high. By increasing the frequency, reactance is going to decrease and output is decreasing. By increasing frequency, reactance of the capacitor is decreasing. The capacitor C1 is decreasing. Therefore, V output is decreasing. Is decreasing. Therefore, now its plot is like this. Frequency, and it is the magnitude V output by V input. So once frequency at low frequencies, see this, at low frequency, at zero frequency, capacitor is open circuited. Now output is equal to input because current through that is zero. Now maximum gain you get. Next, by increasing the frequency, reactance of the capacitor is decreasing. Initially it is constant and finally it is decreasing. This is the low pass filter, and at the same time, at high frequencies, gain is decreasing. Okay. So this is the, so output is low, input, so its gain is 1 here. Okay. This is your low pass filter. Now I am going to getting the same frequency response or gain for a circuit. Here now I am taking a CE stage, common source stage I am taking with the load capacitance. With the load capacitance. common source stage with load capacitance. First I am taking circuit diagram. So output we are taking, and it is RD, we know that. Now here I am going to taking a load capacitor CL. Let us take a device M1. Okay, now in this one, say this, once we provided this capacitor CL, what happens is, at low frequencies whatever the load capacitor we have, your capacitor is going to be open circuited. Now the signal current is going to be produced by this M1 is going to the RD. So at low frequency CL is open circuit, and the current provided by, or the current produced by M1 is flowing through the RD load. Going through RD. Okay, just if you observe previous case, if once at low frequency, 0 frequency capacitor is open circuit, now the current is flowing through only R1. In this case also same thing, here current is flowing through only RD in this case. Okay, now why it is flowing through that? Because your capacitor is open circuited. Why? Because the impedance, if you observe, the impedance of the capacitor is, impedance of C1 is 1 by SC1, and we know for sinusoidal S is equal to J omega. Once it is J omega, omega is 0. Okay, now that is the case. Now at high frequencies what happens is, at high frequencies this capacitor CL, what we have, at high frequencies capacitor C1 is, see, frequency increasing, reactance of CL is decreasing. That means it steals some of the signal current through it. Okay, and frequencies, the reactance of C1 is decreasing, of C1 CL is decreasing, and allows some part of the current through it, and allows some part of the current produced by the device, some part of the current produced by the M1, Okay, So this is that higher cutoff frequency, high frequencies. Okay. Now, once, see this, at low frequencies, maximum current is flowing through RD. That's why high voltage swing. In this case, this is the case at low frequencies. This is the case at low frequencies. At high frequencies, it is also allowing some of the current. Okay, some of the current is flowing in through this one also. Whatever the current providing this, some current is flowing through this. Now little bit current is flowing through this, some current is flowing through this. Okay. Now once current flowing through this RD is decreasing, now the output voltage swing is going to be decreasing. Okay. Therefore output voltage swing is decreasing. Output swing is decreasing. Voltage swing is decreasing. Okay, this is takes place at high frequencies. Okay, and we know that now I'm going to writing its output, and before going to output I'm going to replacing your device by its small signal equivalent. So this is your device. Now I'm going to writing its a small signal equivalent. So this is the gate. It is the gate. Source connected to ground. Here is a GMVGS. Now I am going to assuming, let us take lambda equal to 0. That means I am considering channel length modulation, GMVGS, and after that RD and RL across this. Is RD, RL, CL. Here we are taking output. That is the device. So it is CL. Okay, now from this we can write output voltage is equal to minus of, and this is VGS. Here you are applying input voltage. At a gate you are applying input. So VGS is nothing but an input voltage. Now output, V output can be written as, just both are these two are parallel. Now the current flowing through this parallel combination is GMVGS minus of GMVGS into RD parallel with 1 by SCL. Now VGS is nothing but a V input. Therefore its gain is V output by V input, which is equal to minus GM into RD parallel with 1 by SCL. That's it. Okay, that is the case. See, so far we got the gain. Okay, like that you can analyze. Now, generally for a given function, given circuit, what we are doing is we are going to calculating the transfer function. First of all, what is the relation between transfer function and frequency response? First of all, I am going to getting that relationship between transfer function and frequency response. Transfer function and frequency response. frequency response and relationship between transfer function and frequency response. Generally, we are representing the transfer function like this. So transfer function is representing by h of s. That h of s is represented by a naught into 1 plus s by omega z1 into 1 plus s by omega z2 so on, divided by 1 plus s by omega p1 into 1 plus s by omega p2, like this. Omega z1 z2 are the zero frequencies, omega p1 and omega p2 are the pole points, pole frequencies. Okay, now here in this, whatever the a naught, here we have this a naught is the low frequency gain. A naught is the low frequency gain. Now h of s belongs to a naught at a condition of s tends to 0. If s is 0, all these things are 0, and h of s belongs to, h of s is equal to a naught. Therefore, when h of s tends to a naught as s approaches to 0, when s approaches to 0, it becomes 0. Okay, here omega z1, that means omega zf, here z1 z2 z3 we are using, okay, zf comma omega pf are the zero and pole frequencies of the transfer function, are the zeros and poles. Are the zeros and poles of the transfer function. Okay. Okay, now let us, I am going to taking some input. Okay, now let us take input. Let input is x of t. I am representing by a cos 2 pi of t is nothing but a cos omega t. We are representing it. In that case, then the output is represented by function is represented by y of t equal to a into magnitude of transfer function at s is equal to j omega into cos of omega t plus phase angle of the transfer function at s is equal to j omega. Okay, now here it is the magnitude of h of s by taking s is equal to j omega, and similarly h of it is phase angle of h of s by taking s is equal to j omega. Okay, so just before what we mentioned is just we represent some input data. For that input data, based on the transfer function, we represent the output. So input is A cos omega t and output is A magnitude, and here is the phase angle. A into magnitude of the transfer function into cos of omega t plus phase angle of the transfer function. So this is very, very important, sir. General way of representing input and output in terms of transfer function with the help of transfer function. Okay. Now, let us, I am going to taking a problem. So, here I am going to taking a common source stage, finding the transfer function and the frequency response of it. Find the transfer function and frequency response of find the transfer function and frequency response of common source stage shown below. So here I am representing that common source stage. So input plus VDD RD, it is CL. CL. For this you need to calculate transfer function and frequency response. Just before we calculated this voltage gain or V output mentioned already. Okay, now just go and take that. So we know that output is V output is simply minus GMVGS into RD, capital RD parallel with 1 by S into CL, and here VGS is nothing but a V input. Therefore V output can be represented by minus of GM into V input, which is RD parallel with 1 by SCL. Now therefore voltage gain is minus GM into, therefore transfer function is nothing but a V output by V input, simply V output by V input. V output of S divided by V input of S. That means everything I am taking in S domain. That's it. Now it is minus GM into RD parallel with 1 by SCL. 1 by SCL. Okay, that is the transfer function. Just simplify this. Therefore, H of S is minus GM into, this is parallel, so it is RD into 1 by SCL by RD plus 1 by SCL. Therefore, H of S is minus GM into your RD into 1 by SCL divided by RD plus 1 by SCL. Simplify this. Minus GM into RD divided by 1 plus S into RD into CL. RD into CL. Okay. Now for sinusoidal we can take S is equal to J omega. Now this is your transfer function, sir. This is your transfer function. Now H of J omega is minus GM into RD by 1 plus J omega into RDCL. Now I am going to assuming let omega L is, okay, first take magnitude at the same time. Omega L is 1 by RD into CL. 1 by RD into CL. Therefore, H of J omega is minus GM into RD divided by 1 plus J into omega by omega L. Omega by omega L. Okay. Now, therefore, first I am taking magnitude. H of J omega is GM into RD divided by square root of 1 plus omega by omega L whole square. Okay, let at omega equal to omega L, magnitude of H of J omega is nothing but a output by input is equal to GM into RD divided by root 2, because omega equal to omega L we are taking. Let omega equal to omega L. At that point, output by input is GM into RD by root 2. Okay. Now I am going to placing this. Now if you plot this, its plot is like this. This is the gain, magnitude of gain, V output by V input. It is the frequency on x-axis. At here, initially low frequency, your capacitor is open circuited, already we discussed, and its gain is maximum, and at high frequency your gain is decreasing. Okay, and here this is called bandwidth, minus 3 dB bandwidth. Minus 3 dB bandwidth, and this is the point, a frequency which is 1 by RD into CL, okay, 1 by 2 pi. At this frequency it is going to be decreasing. Now this is going to be minus 3 dB roll off, we call it minus 3 dB roll off it is. Okay, so this is the way of calculating, and this is going to be the lower cutoff frequency of that amplifier. So therefore, sorry, this is the higher cutoff frequency. Okay, so FH is equal to this much. Higher cutoff frequency is 1 by 2 pi RD into CL. Now after that, roll off rate is minus 3 dB. Okay, this is the way you can easily analyze that. Now, so to best understanding of this frequency response, we once again we remember the body's rules. Now I'm going to first writing that. Body's rule. Okay, we have two rules. I'm writing that rules. First one is, see, as omega, that means frequency passes each pole frequency the slope of mod h of j omega decreases by 20 decibel for decay. 20 decibel for decay. Okay, it means a fold change in h for a 10-fold change in h for a 10-fold increase in frequency. By increasing frequency 10 times, h is decreased by 10 times. That is the meaning of that. Second point is, as omega passes each zero frequency, as omega passes each zero frequency, the slope of h of j omega magnitude increased by 20 decibel for decay. Once it is passing through pole, magnitude of the transfer function is decreased by 20 decibel for decay, and once it is passing through each zero, the magnitude of transfer function is increased by 20 decibel for decay. This is the body's rule. Now we use this one in the analysis of your amplifier's frequency response. Okay, now just a minute. Next one. See this. Now let us construct the body plot for h of j omega for common source stage. Construct body plot for body plot of h of j omega magnitude for common source stage. Okay, see, this is the common source stage what we have. For better understanding, I am going to using this single circuit. So that is here. Already we derived h of j omega magnitude for this. That is, okay, let us take h of j omega first, which is V output by V input, which is minus gm into rd by 1 plus j into omega by omega L, where omega L is, sorry, omega h. Okay, as you wish. Better to take omega dash, it is easy to you then. This is f h, and better to I am taking this is omega h. Where omega h is 1 by rd into cl. Okay, and here there is a pole frequency. Here pole is there. That pole frequency is this one, 1 by rd into cl. Okay, 1 by rd into cl, that is the pole. Now its plot is like this. Frequency means you can take out. Now I am taking the log plot. So this is a log omega, and it is the, in decibels I am taking, it is 20 log V output by V input. Everything in taking in terms of logarithmic scale. Now its maximum gain is gm into rd magnitude. Now when it reaches the omega p1 pole frequency, its roll off rate is 20 decibel per decade. So this is a minus 20 decibel per decade. When it reaches pole frequency, it is going to decrease. Our roll off rate is 20 decibel per decade. Okay, this is the body plot. Okay, next I am going to taking another circuit. So here is another circuit. Determine the poles of the circuit shown below figure. Shown below figure. Shown below. So the circuit is supply VDD. At input side, So this is the input capacitance C in. This is a RS source. It is the input voltage. RDCL. Okay. M1 device. For this circuit, need to calculate the pole frequency. Okay. Now, in this circuit, let us take V input 0. Once you connect V input 0, in terms of C input, we need to check. Here 2 poles you get, because 2 capacitors here you have. You get the 2 poles. Okay. If input is 0, if you take, let us in this case, if you connect this one to ground and the input current to this one is 0 amperes, that means it is open circuited. Now in this direction, if you check, the resistance is only RS. Now it is going to provide one pole, therefore the W pole 1 is 1 by RC, RS into C input. RS into C input, that is the pole 1. Similarly, now for load resistor, with load resistor already we observed it is, with respect to CL there is another pole. Okay, now this WP1 is the input pole and it is going to be output pole. Similarly output pole is WP2, which is 1 by RD into CL. RD into CL, that is the output pole. Now from the knowledge of these 2 poles, and this is the input pole it is. From the knowledge of these 2 input pole and output pole, I am going to design rating its gain. Okay, and at the same time low frequency gain we have. Gain is, we know that, minus GM into RD. Okay, from this I am going to defining the transfer function. So magnitude of V output by V input is, magnitude of V output by V input is equal to GM into RD. Magnitude we are taking, so no need to take negative, by square root of 1 plus omega by omega pole 1 whole square into 1 plus omega by omega pole 2 whole square. Okay, this is the transfer function and possible poles for this. Next we take another circuit and we calculate the poles for that. Next, compute the poles for the following circuit. So the circuit is like this. load capacitor, it is RD. Here we are applying input. Sorry, it is input and it is biasing voltage. Here it is biasing voltage. This is the circuit. For this circuit, you need to calculate the poles. So two capacitors here we have. One is input capacitance, other one is output load capacitance. So due to this you get one pole, and due to this you get the another pole. Okay. Now we analyze this. Now says, so this is the circuit what we have. For this I want to calculate input pole. To calculate the input pole, in this direction let us take input is 0, input is 0, and in this direction you need to take, and the resistance seen looking into this side is to drain end, it is going to be 1 by GM. Okay, that means the equivalent is, now the equivalent of this one is like this. This is your capacitor. It is your RS. Now RS as well as 1 by GM connected. It is 1 by GM. This is C input. Now from this input pole or WP1 is 1 by RC. RS parallel with 1 by GM into Cn. Into Cn. That is the input pole. Okay. Similarly, we need to go for output pole. Okay, so to calculate the output pole, the circuit is similar to the previous circuit what we have. So similar to previous case, previous circuit, we can write output pole WP2 omega P2 is simple, it is 1 by RD into CL. This is output pole. These are the two poles of the circuit, input pole as well as output pole. So we need to calculate the poles itself, these two poles itself. Okay. Now let us take another one. So we take another circuit. So you can expect this type of problems in examinations. What are the, how many poles are there for the circuit, or calculate the input pole and calculate the output pole, like that. So now I am taking a simple CS. So next circuit is here is input, it is VDD, RD, RS source resistance, and there is a feedback capacitor I am incorporating into this. CF, taking output from this. For this, calculate the poles. To calculate the poles of this circuit, first you need to apply Miller's theorem to that. Okay, first we go and check that Miller's theorem. After that, we apply that Miller's theorem onto this circuit. First, what is Miller's theorem? Now, Miller's theorem. First, I am going to be applying Miller's theorem. Miller's theorem. Okay. Now, according to this Miller's theorem, let us take a circuit or an amplifier as you wish. Let us take its gain is A. Its gain is A. This is the input section and this is output. An element is connected in feedback. A Z element is connected in feedback. That means between output to input, it is feedback. Now, it's whatever the feedback element here we have, we need to take its equivalent at input as well as equivalent at output. Now, we can write this one like this. Same amplifier. Same amplifier I am taking here. Its gain is A. Here is input. Here is output. Now, this Z can be replaced by at input side by Z dash or Z1, and its output can be, in output it can be replaced by Z2, where Z1 can be written as, Z1 is Z by 1 minus AV, 1 minus A, V. AV means voltage gain, output voltage by input voltage. So here AV is V output by V input, and Z2 is Z by 1 minus 1 by AV, 1 minus 1 by AV. That is the Z2. Now, in case of capacitor, if in place, okay, this is about Z. For example, capacitor is present. If capacitor is present at feedback, this is amplifier, its gain is AV, input voltage and output voltage. Now, let us, a capacitor is connected in feedback, CF. Now, it can be written by same amplifier, voltage gain AV, V input, V output. At input side, we can replace it by a capacitor, as well as output also we can replace by a capacitor. And input capacitance value is CF into 1 minus AV, and here CF into 1 minus 1 by AV. Okay, this is the concept we are applying. Miller's theorem concept it is. Now we are applying Miller's theorem on the circuit what they given, because in this circuit we have a feedback capacitor. Now, by applying Miller's theorem, Miller's theorem. The circuit became like this. Source connected to ground, drain connected to RD. It is VDD RD. Output. At input side we have, it is V input RS. Now at input side there is a capacitor C in. At output side CL. Okay, otherwise we'll do one thing, C2. Next we write that equations. Now the capacitance values are C1 and C2. Now where C1 value is CF into 1 minus voltage gain AV, and we know that for this circuit voltage gain is minus GM into RD. So we know that voltage gain value GM into RD for that. Now just I am substituting that value in this, therefore it is CF into 1 minus of minus plus GM into capital RD, because it is a common source amplifier. Similarly C2 value is CF into 1 minus 1 by AV, which is CF into 1 plus 1 by GM into RD. 1 plus 1 by GM into RD. That is the capacitance C2. Okay. So far we got the two capacitance values. Okay. Once you know those two capacitance values, now write simply input pole and output pole. Therefore, input pole WP1 is, or W input is 1 by C1 into 1 by RC, RS into C1. So input pole is 1 by WP1, which is 1 by RS into C1, which is 1 by RS into C1 value is CF into 1 plus GM into RD. And you can write the input capacitance of the circuit is input capacitance Cin is, it is very simple, simply C1, which is CF into 1 plus GM into RD. You can expect this question also. What is the input capacitance of the circuit? By applying Miller's theorem and calculating the gain, you need to substitute in that. After that only you get the input capacitance. Okay, that is the input pole. Next, output pole W out, output pole WP2, which is 1 by RD into C2, which is 1 by RD into C2 value. Already we calculated C2 value. CF into 1 plus 1 by GM into RD. CF into 1 plus 1 by GM into RD. Okay, this is output pole. Okay, so these are the two poles present in that and at the same time sometimes they will ask output capacitance also. So output capacitance is Cout is equal to Cf into 1 plus 1 by Gm into Rd, 1 plus 1 by Gm into Rd, that is the output capacitance. So far what we done is, for a given circuit we calculated input capacitance as well as output capacitance. These two we calculated. Okay, next one. Generally, if you are taking a frequency response, it is represented in a different format. So this, our general frequency response is like this. Generally, we are representing like that one like this: V output by V input as a function of, in S domain, is some resistance R1 by R1 plus, let us take 1 by SC1. Okay, now here I am going to taking the circuit like this. For low frequency reactance is high, it is not allowing. For high frequency capacitance short circuit it allows, so it is high pass filter. Previously we observed low pass filter, now it is high pass filter. It is high pass filter means it gives the lower cutoff frequency. Previously we studied high pass filter, low pass filter. For low pass filter provided higher cutoff frequency. Now this is a high pass filter, it gives lower cutoff frequency. So this is the output representation from this. Okay, and by simplification we can write S R1 C1 by 1 plus S R1 C1, and magnitude we can write from this as R1 C1 into omega by square root of 1 plus R1 C1 into omega whole square. Now we can take R1 C1 as some omega 2 like that. Okay, or omega L, lower cutoff frequency. Okay, now I am applying the same thing in a problem. Here I am going to taking a problem. See this. See this. Now the problem is, so in a given source follower, circuit, in a given source follower circuit, the given source follower circuit is used in a high quality audio frequency. High quality audio frequency. amplifier. Sorry, no need of frequency. High quality audio amplifier, that's enough. High quality audio amplifier. Here Ri establishes a gate bias. A gate bias. Voltage equal to VDD for M1 and I1 denotes the drain bias current. Drain bias current. Drain bias current. Assume lambda equal to 0 and trans conductance GM is 1 by 200 ohms and R1 value is 300 kilo ohms. Determine the minimum required value of C1. Required value of C1 and the maximum tolerable value of CL. Value of CL. Okay, so this is the circuit diagram. So it is a source follower, common gate, common drain. So it is supply VDD, so R1 device M1 taking output from here is load capacitance. Here is C1, sorry, Ci, it is Ri, and this is the input. Okay, this is the circuit. Okay, now, so you need to determine the minimum required value of Ci and the maximum tolerable value of CL. You need to calculate these two. Okay, now here we have two frequencies, two capacitors, Ci and CL. So you get two pole frequencies. Two pole frequencies we get. First write down that two pole frequencies. From the knowledge of two pole frequencies, you get the remaining things. Okay, now first pole frequency is omega P1. It is the input pole frequency. Input pole frequency. So its value is we know that 1 by Ri into Ci. 1 by Ci in Ri into Ci. So they given the value of Ri that is 300 kilo ohms. Ri is 300 kilo ohms. Okay, now here omega P1 we need to, from this, what is the value of Ci I want to calculate. For that it is 1 by omega P1 into Ri. The given Ri value 300 kilo ohms. Now what is the value of omega P1? That is the main thing. See, in problem they mentioned clearly source follower used to high quality audio amplifier. Sir, for audio amplifier means your audio frequency. The maximum audio frequency is 20 kilohertz. Now you can use that. So now it is 1 by 20k into R is 300. They given 300 kilo ohms, 300k. Okay, now it is. Now get the value of that. Divided by 6. That is sorry, it is into 2 pi. Omega is 2 pi f. So two into 2 pi is 6.283 k into 3. It is 7.699. So 1 divided by 37.699. That is 0.0265 into 10 power 336 plus 3 9, 10 power minus 9 farads. Okay, so that is the capacitance value. Okay, so just a minute. I think so there is a, what they mention, Ci, sorry, minimum required value of Ci, sorry, minimum they ask. For minimum of for minimum Ci, frequency is 20 Hz, because our audio frequency range is 20 Hz to 20 kHz. So it is 20 Hz. It is minus 6. It is minus 6 farads. So it is 26.5 nanofarads. That is the limitation on that. Okay, next one. So next we need to calculate W2, omega P2, output frequency. For that, this is the current what it provides, is the biasing current, and in this direction you need to take its resistance value, which is 1 by Gm. We know that 1 by Gm. Okay, 1 by Gm of that. So now pole 2 is it is a output pole frequency, which is 1 by Gm into 1 by Gm into Cl, which is Gm by Cl. Now just substitute the values. Okay, here for getting that I am going to take the frequencies. See, next they mention, what they mention is maximum tolerable value of CL. For maximum CL, take the frequency of so now frequency range is 20 kHz. 20 Hz for this minimum and maximum 20 kHz. I am taking this. Now from this we can write CL is GM by WP2. So GM they given already 1 by 200 into omega P2, 2 pi into frequency 20 kilohertz. Just simplify this. 4 into 6.283, 25.132. That is 0.0397. kk. It is into 10 power minus 6 farads. So we can write this is limitation 39.7 nanofarads. That is the limitation on that capacitance. Okay, that is the limitation on that. Okay, thank you. Now we are going to this here. See this, few of the top learners from Unacademy. Tiwari sir, he is IIT topper, having 7 years of GATE and engineering service teaching experience. He is author of the book GATE in 75 days. Ankit Goyal sir, he obtained All India first rank twice in GATE Electrical, and he was awarded President of India Gold Medal in IIT Indore, and he teaches electrical and electronics engineering. Sanchit Jain sir, he is the computer science faculty, having a teaching experience of more than 8 years. And Jaspal Singh sir, he is ex-IAS officer, he got All India 4th rank. He is a scientist, GATE, State Service Exams and PSU topper, and ex-senior GATE ESE faculty. He has a teaching experience of more than 12 years. Here are few more top faculty from top educators from Unacademy. These are the different engineering disciplines available in Unacademy: electronics and communication engineering, chemical engineering, mechanical engineering, computer science and IT departments, instrumentation engineering, electrical engineering, civil engineering, production and industrial engineering. So as we mentioned previous, two plans is there, plus plan and iconic plan. In both the case, your classes are taken care by India's best educators. Interactive live classes are there, structured courses and PDFs, live tests and quizzes. In live tests and quizzes, to show the difference of plus subscription and iconic subscription. In iconic subscription, once you written the test, it was forwarded to the personal coach. You do the personalized test analysis on that. Based on your performance on that, they prepare a proper study planner as well as respect to study material also they will provide to you. By following these two, every student can get success in their examinations. Plus plan. See, in plus plan different subscriptions are there: 1 month subscription, 3 month subscription, 6 month subscription, 1 year subscription, 1.5 year subscription and 2 year subscription. And the beauty is here EMI option also available, and by using my code VRAV10 during subscription, you get it by 10% discount. In iconic plan, only 2 subscriptions, 1 year subscription and 2 year subscription. Here also EMI option is available, and by using my code VRAV10 during subscription, you get it by 1 year 10% discount. And don't forget to use my code VRAV10 during subscription. Hit the bell icon for getting notifications. Subscribe us, and please give your valuable comments on YouTube, and join our Telegram group for getting latest updates on our upcoming videos. Thank you very much. Thanks for spending your valuable time with us. Once again, I am welcoming you all to this beautiful online learning platform. Thank you.